So welcome all to the new lecture of medical image processing. So in this lecture, we'll see about the image reconstruction from projections. So that is basically the reconstruction of the CT images. Okay. So like we know what is meant by a CT. Okay, the CT image, how the images are reconstructing everything. So the CT is nothing but it will be like it's an instrument, like it's a imaging instrument. So that object will be there and the object will be there and the X-ray beam will be passing on through the object and it will be detected by the detector in the that is there 360 degree that detectors will be arranged in the CT. Okay, and we'll be getting for each X-ray beam, so we'll be getting each different projections or we'll be telling you the slices of the image, and finally we'll be comparing all the slices and we can reconstruct the original image. So that is the image reconstruction. So before going to the image reconstruction, we should see how we are going to get this projections. Okay, so how we are going to get these projections and how we are going to reconstruct the image from these projections. So how we are going to get these projections, that is called the Radon Transform, and how we are going to reconstruct the images from these projections, that is called as the inverse Radon Transform. So here, so you can see, I hope you can see this picture. Okay, so in this you can able to see that. Okay, so this image is f of m comma n. So like till now we have studied the image as f of x comma y. Okay, so we also see this as f of x comma y. So f of x comma y is the object, and we are going to pass the X-ray source or X-ray beam through this object. Okay, and we will be getting the projections that is in the S-plane. So we are going to get these projections, and you can see that two X-ray beams are there, X-ray beam 1 and X-ray beam 2. Okay, so this X-ray beam 1, it is passing through the origin 0, and the projection is we are getting as G of S comma 0, and the next X-ray beam 2, it is passing from the origin at a distance S with an angle theta. Okay, so that projection will call it as what? G of S comma theta. Okay, so that projection will call as G of S comma theta. So now, what is the normal coordinates, that is x comma y? Okay, x comma y is x and y is the normal coordinates of the object. Then we are transforming into a projection at an angle theta with a distance s. So the new projections coordinates are given by s and u. So I hope you can, they have to given by the new coordinates, that is s and u. So now we are going to see how we are going to get the new coordinates. We are going to get the new projections g of s comma theta from the new coordinates. Okay, so with the help of new coordinates. That is what we are going to see here. So now we'll start the derivations for Radon transform. So now we are going to write. First, we are going to write the equation for. Okay. Sorry, the equation for the image that is passing through, this is g of s comma 0. Okay, so now we are going to write the equation of the first projection that is passing at an angle that is passing through the origin. So now that is given by, okay, so the projection is nothing but, it is nothing but a line. Okay, so the projection is passing through the line, so that we can write the projection as what? X cos theta plus y sin theta. So this is the projection that is as it is passing through the line. It is called a line integral. That's why we are telling it as x cos theta plus y sin theta. So that is the projection. So we can write it as integral minus infinity to infinity, integral minus infinity to infinity, f of x comma y, okay, into del of x cos theta plus y sin theta. Okay, so this is the projection of the line. So as the projection of the line, this x cos theta plus y sin theta is passing through the origin. Okay, so what is this x cos theta plus y sin theta? That is equal to 0. So we can write what? That is del of 0. Okay, so del of 0 into this del of 0, you have to multiply by dx dy. Okay, dx dy. So this is equation number 1, that is passing through the origin. Now we are going to see the equation of the line second beam. Okay, that is passing at an angle S with an angle theta from the origin. So that is given by g of s comma theta. Okay, that is g of s comma theta. So that is given by what? Integral minus infinity to infinity. Again the same equation. Integral minus infinity to infinity. F of x comma y. Okay, f of x comma y into multiplied by del of x cos theta plus y sin theta as it is passing from the origin with the distance s. So how can we write this? So we can write the second line as what? So we can write the second line as x cos theta plus y sin theta equal to s, or else we can write what? X cos theta plus y sin theta minus s equal to 0, right? So we can, instead of this, we can write x cos theta plus y sin theta minus s into dx dy. So this we can write this equation number 2. So I hope you understood how you are getting this equation number 2. So now what we are going to do is a very important thing. We are going to convert this x and y into the new coordinate u and v. Okay. So now we are going to see how we are going to get the new coordinate. Sorry, not u and v, s and v, s and u. Okay. So you are going to get the new coordinate, that is the new projections, right? S and u is the new projection coordinates. That we are how we are getting it from the existing coordinate x and y. So that is given by, so this equation, that is the, we are going to convert the coordinate, that is cos theta sin theta minus sin theta cos theta multiplied by xy. Okay, multiplied by xy. So from this, what can be write? What is s? S is equal to what? X cos theta plus y sin theta, right? And what is u? U is equal to minus x sin theta plus y cos theta. So now I am putting this equation as equation number 3. Okay, so now we are getting the equation for s and u. So similarly, we will see what is the equation for x and y. So what is the equation for x and y? How to get x and y? So x and y is equal to, so this is a transpose of the matrix. Okay, that is cos theta minus sin theta cos theta multiplied by s and u. So from this, what we can write as x is equal to s cos theta minus u sin theta, and y equal to s sin theta plus u cos theta. So I am going to write this as equation number 4. Now what I am going to do is nothing but I am going to substitute this equation 4 and 3 and 4. Okay, I am going to substitute this equation 3 and 4 in equation number 2. Okay, so what I will be getting now? So that is g of s comma theta equal to integral minus infinity to infinity integral minus infinity to infinity f of x comma y, right? So instead of x, what I can write? S cos theta minus u sin theta comma s sin theta plus u cos theta. Okay, and what is into x cos theta plus y sin theta minus s. What is s equation? What is the equation for s? S is equal to x cos theta plus y sin theta, right? So what I am going to do here, del of x cos theta plus y sin theta minus x cos theta plus y sin theta. So that will be equal to what? Del of 0, right? Del of 0 into ds du. Now we are going to convert the new coordinate, so that coordinate will be ds du. Okay, so that is why the x comma y is converted to s and u, because you are converting the x and y into s and u here. So similarly here also the x and y will be converting to s and u. So what is the final equation? So we can write g of s comma theta equal to integral minus infinity to infinity f of s cos theta minus u sin theta comma s sin theta plus u cos theta into du. So this is the final equation. Okay, so this is the final equation, and this final equation will call it as the ray sum. Okay, we'll call it as a ray sum. So now we can see that. Okay, so we are going to, like, what we're going to hit here, we are going to get the equation of one projection, that is g of s comma theta. So what is g of s comma theta? How we are getting? So g of s comma theta, how we are getting this projection? We are getting the projection in such a way that the X-ray beam will be passing at a distance s from the origin with an angle theta. Okay, with an angle theta from the origin. So that is why we are getting this projection g of s comma theta. So similarly, when the X-ray beam is giving a different angle, okay, from the origin, different distance from the origin, so we'll be getting what different projections. Okay, so this is only for one projection, and this we can call that this is nothing but a one-dimensional thing. So this is only for one projection. So similarly, we'll be getting different projections, and this all projections will combine, and we'll be getting the estimated image f cap of x comma y, that we'll see in the next class. So I hope you understood what is meant by this image reconstruction from projections, that is the Radon transform. Thank you.